Hey y'all, it's Sarah. This is going to be the last L'Hopital video in my Calculus 1 series. Today we're talking about indeterminate powers and how to solve for them using L'Hopital's rule. So here's our sort of roadmap here. Basically, indeterminate powers are when we have a limit of a function that involves an exponent, right? So we have some function g of x to the power of h of x. And when we take this limit, it results in either 0 to the 0th power, infinity to the 0th power, or 1 to the infinity power. Now, our first step here is going to be to e to the ln our function, right? And so what we're going to do is, since e and ln cancel each other out, we're going to put the whole thing as a power of e and then ln the function. And so that's going to allow us to move h of x, our power, down outside to become multiplied to ln of g of x. And then we're going to use a little bit of u substitution. So we call this entire exponent here u. And then we're going to solve for u. U is an indeterminate product, so we're going to solve for it like we would any indeterminate product. If you haven't watched my video on indeterminate products, I'll link it in the description. And then once we've solved for that using L'Hopital's rule, then we can plug that back in so that e to the u is our answer. That's our limit. So I'm going to do a little example here. So we have the limit as x approaches infinity of 1 plus infinity to the 1 over infinity power. So if we plug in infinity here, we have 1 plus infinity to the power of 1 over infinity, which is infinity to the 0 power. So that is an indeterminate power. So our first step here is going to be to e to the ln this. So we are going to e it, and then we have the limit as x approaches infinity of the natural log of 1 plus x to the 1 over x power. And so now what we can do is we can take down the 1 over x. So this becomes the limit as x approaches infinity of 1 over x times the natural log of 1 plus x. All right, and now I'm going to let u equal this exponent, right? So u is going to be equal to the limit as x approaches infinity of 1 over x times the natural log of 1 plus x. And so now we're going to solve for this like we would any other indeterminate power. So we have to move one of the things that are in the product, so either 1 over x or ln of 1 plus x into the denominator by taking its reciprocal. Now, 1 over x is already in its reciprocal form, so I'm just going to do that. So I'm going to turn this into the limit as x approaches infinity of the natural log of 1 plus x over x. And so now when we plug in infinity, we have the natural log of 1 plus infinity over infinity. And the natural log of infinity is just going to be infinity. So now we have infinity over infinity. All right. So now this is in a form we can L'Hopital. So the derivative of ln of 1 plus x is 1 over 1 plus x. And the derivative of x is just 1. So this becomes the limit as x approaches infinity of 1 over 1 plus x. So when we plug in infinity here, we have 1 over 1 plus infinity. So this is just 1 over infinity, which is 0. Now 0 isn't actually our answer to the original limit though. The original limit is going to be e to the u, right? So here that is going to be e to the 0, which is 1. And so 1 is actually going to be our answer. All right, if you enjoyed this video, please like and subscribe, and I'll see y'all next time.